So what we're showcasing here is a ONOS system test architecture. My name is Subin Zhang. I'm from Open Networking Lab. So here is a poster of our architecture. First of all, we have built ONOS system test with an extensive set of test suites, including functionality, high availability, performance, longevity, and use cases. And we are, on the testing point of view, we are open source ourselves, and our test framework is based on Python. And then because of the flexibility, extensibility, and debuggability, we were able to build this full set of testing in a very limited amount of resources. But if you look at the architecture itself, we have a test cluster that consists of a number of ONOS nodes, and then we have a test station that's executing the tests. By segregating different networks in this test cluster, we have a lot more flexibility writing test case to execute different scenarios. So this kind of cluster can be replicated multiple times to get the load sharing of it. And then we use the industry pretty standard open source CI tool, that's Jenkins, to orchestrate this whole test setup, including pulling the latest code from ONOS and the test code, and also when the test is finished, publish out the results. So a little bit deeper look into a test on, which is running inside test station for authoring and executing test cases. We compartmentalize different concerns. First of all, test cases are put into a folder with param files, topo files, and dependencies. And the actual test, the test logics run in the .py file, which call on a set of drivers that we have written quite extensively for ONOS and some of the test emulators such as Mininet. And you can easily extend this test driver to other kind of components, such as hardware switches and so on. So we will be demoing a scaled down test case for SDN IP testing. It's a case that we modify from our actual SDN IP testing. And John will be explaining that, walk you through the demo.
Hi, I'm John Hall. I'm from Santa, and we're going to show you a test of SDN IP. So before we get started, we're going to talk a little bit about what SDN IP is. So if you have a traditional or an SDN network, and you want it to connect to traditional legacy networks, you can do that through BGP peering. So you have your Quagga routers that are peer with it, and you'll have your ONOS on top of your SDN network controlling it. It has a SDN IP application, and it will speak BGP to the Quagga routers. So we'll create a tunnel to connect the Quagga routers with the BGP, and it'll speak normal standard BGP. So advertise the routes, and then ONOS will take those routes and convert them to intents, and then it'll calculate flow rules that it needs to satisfy those intents in such a way that you'll have end-to-end connectivity amongst your different ASs. So that's the basic of the test. And so I'll now show you an example of us running that test in an automated fashion. So here we have a screen divided into 4 quadrants. The first one is a GUI of a simple test that we're doing, that we're going to show you. Similar to the poster that we had before, we have Jenkins, test on ONOS, Mininet, Garrett, and the wiki. Up here we have an actual production Jenkins environment, and this is where we'll start the build. So you can say build. Let's see. And you click build. Oops, I have to log in. And now the job is running. So here the job it'll give you messages, say what's happening. So while it's getting setting up, pulling the code and cleaning up the environment and then getting ready to run tests on. Down here, what will happen is this is the test on log. So as the test is running, it'll go through that. And then this is the test on code that will scroll in sync with the logs so you can see what the code actually looks like when we're running our test. So now you can see that test on is started. It's connecting to the different ONOS nodes. And then after it does that, it's going to start Mininet and connect to that. So while it's taking its time to run, you can look. We have cases. Our test is divided into cases, and each case has a step, and then each step has an assert. So we do something like check the topology, make sure that there's, we have 100 links in our network, make sure that there are actually 100 links in ONOS. And then if any of those assertions fail, it'll cause a step to fail, which will cause the case to fail. So right now, we just started SDN/IP application, and now we're creating tunnels between the routers and the SDN application. So now we're pinging it across that just to make sure that they can actually communicate. Now we're checking that the routes from the routers are in ONOS, and checking that the intents got installed. And then we're going to check the flows. And then after we check the flows, we're going to ping from hosts in these ASs across to the other side of our SDN network. And then we have one last test. So there's just to show what will happen when something fails. We're checking the ONOS logs for any warnings or errors. In this case, there's some warnings. So you see one test case failed. The other 8 passed. So now that the test is done, if you saw, Jenkins published the result to the wiki. So we now can go to the wiki, go to the exact page with the results, and the results were just published. So we can scroll down, see that everything passed, except for the last test that failed. So that's our continuous integration environment. So we have a suite of tests that we run every night and post to the wiki. Thank you.